In the previous video, we saw how negative numbers are stored, right? Now we will look into write a program to print each individual bits of a negative number, just to make sure that they are stored in a way that we discussed. All right. Then we'll confirm with our website. All right. Okay. Before we go into that, let's look at a let's pretend we have a number n4, n3, n2, n1, say n0. This is each is a bit, a 5-bit number, 5-bit number. Okay, n4, n3, n2. This is any number like 5 bits, like that. Okay, n4 is this, n3 is that, n2 is that. Okay, good job. So let's take the 5-bit number. Now if you want to print n4, we need to shift this whole number by 4 bits, right? n4, n3, n2, n1. That's one time. If you shift right, once you get this number. You shift 2 times, you get n4, n3, n2. You shift 3 times, n4, n3. Shift 4 times, you get n4. But unfortunately, we will be getting a lot of other things. We don't want it. Usually what we do is, after we shift this 4 times, shift 4 times to the right, we need to AND with 1. Bit AND. This is not logical AND, this is a bit AND. Alright. So when you bit AND, this n4 with 1, so if n4 is say 0, bit AND with 1, it will be 0. If n4 is 1, bit AND with 1 will be 1. Right? So if n4, we remember that. All right. Then you print that value, whatever that value is. Right? If it's 0, you print 0. If it is 1, you print 1. So that is how you do it. To print n4, to n4, you shift 4 times. How about n3 now? If you want to print n3, you shift 1, means we get n3, n2, n1. Then you shift 1 more time. Then you shift 1 more time. Then you bit AND with 1. So if n3 is 0, bit AND with 1 will get 0. If it is 1, bit AND 1 will get you 1. So that solves that problem. Alright. So similarly, if you keep printing, now we got n3. Now we need to print n2. If you shift again, next iteration, you get n2 and 1. If you shift 1 more time, then you AND with 1. You get n2. Similarly, n1, it goes on. That's the way you print. The reason we have to do all this shifting business and logical and bit AND is the individual bits in a byte is not accessible. The individual bits is not accessible directly. Okay. That is why we had to do all this magic. Okay. So let's write a program. I've written this program here. Okay. I've taken a number 22 in a for loop. Because 8 bits, we need to start with 7. So I'm shifting that number by initially by 7, then AND with 1. We always AND with 1. All right. Then you print that value. Okay. Here in this case, I'm sorry, 1 second. You have, let's say, 1010 0010, whatever the number is. If you want to print that guy, it's 8-bit, right? It's 8-bit. You shift, if you shift right, become 1010 001, right? This falls off, right? Then again you shift. So you have to shift 1, 2, 3, 4, 5, 6, 7 times to get that 1. The next 0 to print, you need to shift 6 times. This one shift 5 times. That's what it is. And I adding it. Okay. Let's compile this guy. So 22 is represented as, in our computer, look at that guy, and with what we have, if you compare it, 1110, we have 1110 1010 for minus 22. If you compare for say minus 33, for example, so 33 is represented as that. If you go back and plug it in, I think that's what it is. We have there, you see that 11110101, then all ones. You see that? So we have confirmed how to convert a negative number, then we confirmed with our program. Okay, thank you.